Most sounds are transmitted through air, but liquids and solids transmit sound too. Both are very good conductors of sound. The speed of sound is different in different materials. In general, the speed of sound is faster in liquids and still faster in solids. The one place sound can't travel is in a vacuum. Sound needs a medium to travel. An object that vibrates normally would create sound, but if there's nothing to compress and expand, no sound is made.
This annoying ringing bell cannot be heard because there's no air in this chamber. But if I let air into the chamber, the sound can travel through the air out into the room.
If you watch a baseball game from up high in the stands, you'll see the ball hit before you hear it. You also hear thunder after you see lightning. Both of these situations are evidence that sound travels much slower than light. The speed of sound in dry air at 0 degrees Celsius is about 330 meters per second. This is about 1/1,000,000th the speed of light. The speed of sound in air increases with temperature, about 0.6 meters per second per each degree Celsius. The speed of sound in a solid depends on the elasticity of the material. Sound travels about 15 times faster in steel than in air and about 4 times faster in water. The intensity of sound is proportional to the square of the amplitude of the wave. Loudness differs for different people, although it is related to sound intensity. The unit of intensity of sound is the decibel, named after Alexander Graham Bell, inventor of the telephone. The decibel scale for loudness is logarithmic. Starting with 0 decibels, which is the quietest sound for normal hearing, an increase of 10 decibels means that the sound intensity increases by a factor of 10. 20 decibels is not twice as intense as 10 decibels. It's 10 times as intense, or 100 times as intense as 0 decibels. 30 decibels is 10 times as intense as 20 decibels, and 1,000 times as intense as 0 decibels. This chart shows the levels of some familiar sounds. Hearing damage begins at around 85 decibels. The damage depends on the length of time of exposure and on frequency characteristics of the sound. Prolonged exposure to high sound levels can cause nerve damage to the inner ear's receptor organ. Unfortunately, the nerve cells do not regenerate and the damage is permanent.